Hello, everyone. So this is the part 2 of my final exam review of Math 25. And today we're going to talk about more like advanced topic of the class. They're mainly about like arc length, like center mass, and solving for separable differential equations. So today emphasize is going to be arc length. Number 2, it is center of mass. Number 3, it is solve for differential equations. Differential equations. So we just chose like a random questions from old final exam archive. So we're just gonna like do a practice problem, and I will also send those the note and recording after this like review, and hope you guys I think it's helpful. So the first question we are talking about it is autumn 2019 question 7. So it's write an arc length for. Can you see my screen here? So it's arc length for y equals to e to the x squared from x to 0 to x equal to t. And one thing about like arc length integral, it is there are a lot that we cannot integrate with our current method learned, so we just write up but don't evaluate the integral. So recall the arc length equation has L arc length from A to B will be square root over 1 plus f prime of x squared dx. That's just the integral equation, and we just take the derivative of this integral by chain rule. Y equals to 2x ex to the squared, and now we found like you can't just evaluate this integral because like if you find this arc length, that you will not get any kind of an easier answer for this one, because you have is going to be 1 plus 2x ex to the squared and squared. And that's going to be like very nasty integral that to evaluate. So that is the arc length expression. Well, if you put them in the simplify a bit, this is what we should expect. Plus 4x squared e to the x to the 4 dx, but we can't integrate it because it's hard, and it's like hard to integrate this function. And now the arc length. Another arc length I would find it is the spring 2018. For this question, it's just like arc length for y equals to 1/16. This arc length is for y equals to 1/16 e to the 2x plus e to the negative 2x over this interval 0 to 1. We want to find the arc length. The first step, we need to find what is the y prime. Y prime by chain rule. There's a lot of things we use the chain rule. Here's my chain rule again. It's gonna be I got 1/8 e to the 2x minus 2e to the 2x. And we want to find the arc length, and then we have this interval, we have this derivative. So we just set up integral. Okay, I think that's gonna be arc length integral that we have right now, and we just I just write out like this integral. We do some algebra here. We expand it, having plus y in there. This will be the arc length expression that you were going to integrate. Actually, for this one, it is integrable. You're missing a e to the 2x. And this is arc length expression that we are expecting. So let's find like another arc length. Not the graph one, but is let's find another arc length. Okay, this is going to be Autumn 2016. So the arc length is not in every quarter, so it's not like a big concern of it. Question 4. So we had this function in this arc length. It's going to be y equals to natural log of x squared plus 1. We have a boundary going to be t smaller than x, smaller than 2t. We just set up this arc-length integral. So we need to find the derivative by the chain rule. So this is like another chain rule that we're gonna encounter. It's gonna by chain rule gonna be 2x over x squared plus 1, and the arc-length integral is gonna be 2t and t. We just assume they're positive, and we just gonna be like 2x over x squared plus 1 to the squared dx. I think that's probably it, because like you probably can't write like even further. It's like yeah, because this is a nasty integral. So this is what we can expect. Okay. There's like another arc length. As of 2015, I think question 8. So it's like a y equals to, yeah, this is the arc length again. So it's just a y equals to sine of x, and there's already interval for 0 x over pi over 2. They ask for like the setup with the integral, so we don't need to integrate it, and we just write out this integral, and we have is y prime, it is cosine of x, and we just have this integral pi over 2 and a 0. One plus cos x is squared. There's no, I think it's like a no more trig identity that I can use for this integral, because like a trig sub is impossible here. Otherwise, I don't think there's like alternative for like a nicer integral that I can write it here. I think this is like the arc length integral that we expect. Okay, I think gonna be the last one, the arc length. So this is gonna be winter 2014 question 7. It's like another arc length. So it's a y equals to sine of 2x. Interval come from 0 to pi over 3. So we find the derivative by the chain rule again. So it's going to be 2 cosine of 2x. And just we'll make the derivative, just there's no need to change the bound because you're given the integral. You're given the integral that you need to integrate like arc length. So we just like write up the integral. Power 3 and a 0. Cosine of 2x and then squared dx, and then we just rewrite just to make them either, but we don't need to integrate this integral because it's hard. And sometimes it is nearly impossible to just integrate. Is such integral is hard to integrate. And I don't think the trick can solve this integral. So this is, I think, all like arc length integral that I discussed so far. So we're gonna move on to the arc. So we're gonna move on to like the solve for the initial problem right now. So now let's talk about solve for the initial problem. It's like solve for like differential equations. So going to within 2018 question 9. So we have this is gonna be so we're having this y prime, it is x to the y to the cubic over 1 plus x to the squared. And given the initial condition is a y0 is -1. So find this y equals to what? So actually, it's not going to use some like the tricks up. I think this time it is like you probably have used the tricks up. Okay, let's get started. So separable different equations. So you just separate the variable first. So what we could do in this case is like we have as a y prime, we write them as dy dx. So the x term is in here and the y term is there, but this time you probably don't need to like trick sub or use sub, whatever it is. So we have y to the 3, we have kind of a 1 over y to the 3, and it's over 2 x over 1 plus x is squared here. I have this. We'll just write up new integrals. two new integrals. So we're gonna have it's gonna be y to the negative 3 dy equals to this. The expression remain unchanged. Dx. New integral, we have y to the negative 3 dy equal to x 1 plus x squared dx. I think for this one, I think don't need the tricks because you can do with like a U-Substitution done. Or tricks up is just a harder way to do. But if you're like if here is x squared, then do tricks up. So we're gonna have 1 plus negative 3 negative 2 over 1. So gonna be negative 1/2 y to negative 2 plus constant of integration plus we here make a U-Substitution here. We have going to be 1/2 the integral of 1 over square root of u du. This remain unchanged. So going to be 1/2 over u to the negative 1/2 du. And we have this integral going to be 1 over negative. It's going to be like a negative 1 plus 1/2 over 2. So it's going to be 1/2 y to the negative 2 plus constant integration. It's going to be 1/2 times 2 u to the 1/2 plus constant integration because they're the same thing. So we need to cancel one c in one side. So we're going to be negative 1/2 y to the negative 2 equals 2 u 1/2 plus constant of integration. And we substitute the u back, so we need to plug in the initial condition here. So it's gonna be 1 plus x squared 1/2 plus kind of integration. So it's like y equals y 0 to negative 1. So plugging x equal to a 0, y equals to negative 1. So it's going to be negative 1/2 times negative 1 over negative 2 over it's going to be 1 plus c here. So this is going to be like a negative 1/2. So c is going to be negative 3 over 2. And then we have I think gonna be -2. I think it's like the you should like a negative. Is it gonna be like a -2u? Yeah, I think that just to make a mistake, but that doesn't matter, right? It's like if I sorry if I'm making a mistake here. It's gonna be like I forgot like a -2 here. So times. Oh wait, never mind. Here gonna be -2. So as long as we have c equals -3/2, once we multiply by y equals -2 here, we multiply them by 2. We multiply them by -2. So we get gonna be -2. 1 plus x is going to the squared 1/2 and plus 3. Just multiply it all sides by -2. It's a square, not a cubic. And now you just needed to now gonna be -2 power, and you finally just make the y is gonna equal to I have y squared. You just make this gonna be 1 over 3 minus 1 plus x is squared over 1/2. Like y equals -1, you already solve for c here. I think you need like another. If you want to do like a negative, then plus like a negative sign here, then you're gonna get a very nasty expression. So gonna be 1 over 3 minus 1 plus x to the squared 1/2. That is your final expression of this separable differential equations. Okay, this is Autumn 2018 question 8. Now there's separable differential equations. Question 8. It has y prime plus x over y minus 1. Equals to 0 here. The initial condition is y 0 equal to -1. Then just solve for y equals to f of x. Just give them in explicit form. Okay, we need to move the term here. I think we need to move the term. We just need to reorganize the thing. We have y. Just to rewrite them as y prime plus x times y over 1 over minus 1 equal to a 0. If we move to like another side, we have the y prime. It is gonna be like a negative x times 1 over y minus 1. If we multiply the y minus 1 to this side, we have a like easier integral. So we just move the term. Just move the term. We multiply it by y minus 1. Construct new integral. Equal to negative x. Y prime is the same as dy dx. Equal to negative x. We construct new integral here. So it's going to be the integral of y minus 1 dy equal to the integral of like a negative x dx. Now we do integration. So it is going to be 1/2 over y squared minus y equal to, it's going to be negative 1/2 of x to the square plus constant of integration. And now we have this expression. I mean, just to try to how to move all the terms here, right? So initial condition is y0, it can be -1. So it's gonna be 1/2 times -1 squared minus -1. It's gonna be a negative 0 plus of integration. The c is gonna be 3/2. Now we have this expression. So we are gonna be negative, not gonna be positive 1/2 y squared minus y equals to negative 1/2 x squared plus 3/2. Okay, and now we need to get rid of this 2. So I multiply outside by 2. Because there are 2, 1/2, they're just if you multiply by 2, the equation looks very nicer. Have y squared minus 2y. It's gonna be negative x squared plus 3. So move them into one side. And it's gonna be y squared minus 2y plus x squared plus 3 equal to 0 here. Now we need to look at there's something that is nice, right? Hint is like Now we just solve for y, and what we have gonna be y because I'm used to quadratic formula. Oh wait, I think I make a mistake when putting here. X squared minus 3 here. And we just can't say, okay, gonna be 4, no. And then we just, y gonna be negative 2b, gonna be negative b plus 4ac, so gonna be 4 to the x squared minus 3 over like a new over the bottom gonna be 2. And then you get us a y equals to 1 plus or minus 4 minus x to the squared. If we plug in y equals to 0, gonna be negative 1. So gonna be, and they're gonna be 2, 1 minus 2 gonna be negative 1. So y equals to 1 minus 4 minus x to the squared is our final answer for this questions. Another separable differential equations. Okay, so select outcome 2014 question 9. So we have dy dt, it is t sine t cosine squared of y. Wow, this is an interesting integral. And y is 0 going to be pi over 4. So solve for y equals f of t. Okay, we need to separate the thing first. Now you just trying to so they're gonna be negative. No, because we're gonna multiply the thing. Notice that 1 over cosine of x is secant squared of x. So we have gonna be secant squared of t and the y dy dt equals to t sine t on the right side. Then we just have this integral secant squared of y dy equal to t sine t dt. So we just use integration by part. We use IBP. We are just gonna have this integral ready. Secant inverse is a tangent. So you just have tangent of y plus constant of integration. And it's equal to minus t cosine t plus sine t plus constant of integration. So we move tangent of y plus gonna be negative t cosine of t plus sine of t plus constant of integration. Now we apply the initial conditions is y 0 gonna be pi over 4. So y is a pi over 4. So we plug in tangent pi over 4. It is negative 0 cosine times 0 is a 1 plus sine of it 0 is 0 here. We need to find the tangent of pi over 4. Oh, tangent of pi over 4. This was 1. So 1 equals to C. And so now we try to find it. Now we already have this. So tangent of y is equal to negative t cosine of t plus sine of t plus 1. Anyhow, you have a tangent of y. How are you going to solve in terms of y, right? No way. And then you just need to do this. I think you need to do like inverse tangent because use inverse tangent. Column inverse trick. And then now we just solve them for this. Gonna be y equal to inverse tangent sine of t minus t cosine of t plus 1. I think that is what you expect for this expression. Autumn 2014. Yep, I think that is your expression here. Make sure to use the IBP when you solve like the product and the trick. Okay, let's do another one. I think I found like yeah, another one is like a trick sub or whatever it is. Oh yeah, that's one hard one. It's winter 2014. That's question 9. So we discuss this. So this is like dy dx. It is x plus 3 and y plus 2 over x squared plus 9. We have y is 0 equal to 10. So solve for y equals to f of x. I think this time is like, okay, you probably need some partial fractions here, or you need a trig up. I think you need a partial fractions or trig up. Separate the term. So you move the y term in one side. And you have this. Well, technically you can do U sub and inverse tangent, but it's like trig sub is just like another way to do it. But I would try both. See whatever will work. So construct new integral. We have this integral here. This equal to like x plus 3, x squared plus 9 dx. Okay, now we have two ways to do: easy way or hard way. Easy way it is. We split up an integral. Hard way is a trig sub. So which way do you want me to do it? So I'll do the easy way here, but I will do the hard way after the recording. Okay. Hard way is a trig sub. But you could avoid it. So here's the thing, you could avoid it. Yeah, getting them wrong. So make a U-substitution here. So I don't think it was like a natural log. So this just gonna, we split up the thing, we have like natural log of I plus 2 plus concept of integration on the left side, we can just split it up. We could do a U-substitution here. That just avoid lots of errors if you want to. That make sure that you don't make any errors. This one is like straightforward inverse tangent integrals. This one just a very straightforward integrals. So just to keep this and this, I think it's gonna be like another U-sub. Be careful about the natural log here, because those are good, because those are gonna be very nasty here. Maybe that's why that how I just know this, right? F3 equals 3 here is going to be 1 plus inverse tangent of like 3 over x. That's going to be nastier. Well, I hate like a natural log for some reason. That is one of them. Plus inverse tangent of x over 3 plus constant of integration. Now we apply for the initial I realized another error is like, how the y becomes the x, dude? I need to stop making those like stupid mistake here. So it's like a y zero equal to 10. So you have a natural log of 12. We have gonna be 0 gonna be 1/2 of natural log of 9 plus arctangent of 0 plus c here. C gonna be a nasty number, but that is what it can. That is what it can. That is maybe what it can. That maybe is what you may expect on there. As arctangent of 0 plus c. Need to solve for c. Wow, c is a very nasty integral here. C is a nasty number, but it's just going to natural log. It's going to be negative natural log of 1/4. So we put it all together, it's going to be natural log of y plus 2 the absolute value. It's going to be 1/2 of natural log of x plus 9 plus inverse the tangent of x over 3 minus natural log of 1/4. Now you want to solve for y. This will be natural log. I probably hate this. I don't understand. I want to solve for natural log. It's the 1/2 of natural log of x squared plus 9 plus arctangent of x over 3 minus natural log of 1/4. One is solve for y here. So when solve for y, you need to put the e like everything. So you need to put like e times everything. So I was just gonna explain how it's gonna work, but like, so every time we naturalize one solve for y, so we see e times blah blah blah. And we can obtain that. And then it's the y 0 is 10 again. So now we have the y equals going to be 4 e to the arctangent of x over 3. And then we had this x squared plus 9 to the 1/2, and then minus 2. So I will explain this process later. But it's, yeah, but basically you need to turn in like a y naturally to e base, whatever it is. So for 4 straight, like the solvable separable differential equations. So let's do a center of mass. So for center of mass, it's going to be spring 2017 question 8. So region R usually are bounded by y equals to 5 minus x squared, y equals to 4x squared. So the first part is find the area. Find the area of the like region R. So we set them equal, find intersection. So we set them equal, we have 5 minus x squared equal to 4x squared. We get x equal to -1, 1. Be plugging x equal to a 0, then y the 5 over x is on the top. Over -1 over 1, 5 minus x squared is greater than 4x squared. Then we set up the integral. This is dx, and the top minus bottom. So it's going to be 5 minus x squared minus 4x squared dx. So it's going to be the integral of 1 to -1 5 minus 5x to the squared dx. So it's gonna be 5x, gonna be 1 over negative 1 minus 5 over 3x to the cubic, 1 to negative 1. It's gonna be 10 minus gonna be 5 over 3 minus minus 3 over 10. So going to be 20 over 3. And once we have the area, find its center of mass. X bar and the Y bar. We have a region, then X bar it is just have a region bounded. So the X coordinate, it is 1 over area X over half of X minus G of X dx, and the Y, it is 1 over X, 1 over area f x to the squared minus g x to the squared dx. So let's compute this integral here. So x bar is going to be well, don't forget the integral here. Don't forget the integral here. I apologize if I'm making a mistake. So it's gonna be 3 over 20. Why like the bound gonna be 1 and it gonna be negative 1. Have this x. And multiply by 5 minus x squared and minus 4x to the squared dx. So it's gonna be 3 over 20 1 to negative 1. So gonna be 5x minus 5x to the cubic dx. And we evaluate this integral, we're gonna get something like this. Gonna be 5 over 2 x to the squared 1 to the negative 1, then minus 3 over 20 times the 5 over 4 x to the 4th, and you 1 negative 1. And now we need to find the this value here gonna be 5 over 2 minus 5 over 2. So gonna be minus squared. It's gonna be 5 minus 3 over 20. So this is gonna be 8 2/5. We have gonna be 3/2. So gonna be 3/20 minus. So it's gonna be 3/20 times this is gonna be 5/2. So it's gonna be 3/8. That is your x bar. And for y bar, you need to use this integral. So gonna be 3/20, 1 to the -1, and it's gonna be f of x squared. So it's gonna be 5 minus x squared minus 16 to the 4th dx. Evaluate this integral. So it's gonna be 3/20, 1 and -1. It'll be 25 minus 10x squared plus x4 minus 16 to the 4th dx. We just evaluate this integral. It's gonna be 1 about like a -1. It's gonna be 25 minus 10x squared minus 15x to the 4th dx, and the multiply constant is going to be 3/20. Is the constant, and just the sum of y going to be 28/5. And you might find something. Oh wow, this is 5.6, right? This is like out of it is out of the bound, but they do need to find it if there's like errors. Yeah, there's. I think that just basically just the setup of the integral. Yep, that is basically what you're gonna expect over this. Okay. I think that's probably like the all, because it's a column of $1.50. So by the center of mass, I'm gonna reintroduce like the concept that you might need to know for wait, I forgot. So it's gonna be this need to be times y1/2. So times y1/2 times r1/2 is the center of mass should be 5/14. So the x bar, y bar of this question is going to be 3/8 and 14/5. That is your answer. Let's do another center of mass question. Oh no. Okay. So a review of the center of mass. So like the center of mass So if you have like the moment, so if you're given like in the moment, you want to solve for like a moment. So if you're given the density, like the moment, call them M, then gonna be My. It is B to the A X F of X dx, but you're given like the M of X. So it's gonna be 1/2 times density. So gonna be 1/2 B to the A density times Fx to the squared. And if you give me like just like the region, it's like the horizontal region. It's dx integrals. So we have, for example, it's like this. A and B. You want to find the center of mass, perhaps this. Then the X bar, it is the 1 over the area from A to B. X, this is gonna be F of X. This is gonna be G of X. X F of X minus G of X dx. If you're solving for Y bar, so it's going to be 1 over A times the integration of going to be 1/2 times Fx to the squared minus Gx to the squared. Then dx. If you're given like the dy region, so it's like D to C here. And you can find is center of mass. They use this equation. It's like you're gonna be H of X, K of X. So the Y bar, 1 over the area C to D, Y over HY minus KY dy. And for the X bar, and it's going to be it's going to be 2A from C to D. It's going to be HY squared minus KY squared. Dy. Okay, that is all for part 2 of my midterm exam of the final exam review. So the third part is going to be on in the 9.4, which is like hard part of the final and this the whole course. And hope you guys have a great day.